Good morning, dear students. Today we have to continue the third part of the Activity 5, Nature of Nervous Message Recordable Electric Signals. Don't forget to prepare your notebook and a pen and to open your biology book pages 72-73. At the end of this video, you will be able to differentiate between the threshold intensity, ineffective and effective intensities, to deduce that a nerve fibers obey the law of all or none, and to deduce that the nerve response to increasing stimulations is summative. Let's remember the difference between nerve and nerve fiber. Observe this figure. This is a nerve. All of this is a nerve. This is a nerve fiber. So a nerve fiber is a part of a nerve, or a nerve is a group of nerve fibers. This is a bundle or a group of nerve fibers. So a nerve is a bundle of nerve fibers or bundle of axons. If we stimulate a nerve or a nerve fiber, what should we obtain? Do all stimulations give the same response? Are all responses identical? We don't know. Let's see. So in this video, we have to learn the response of a nerve fiber and that of a nerve when they are subjected to stimulations of increasing intensities. Now we have to start by the response of a nerve fiber, which is one axon. So, to make this experiment, we need an axon, one axon, stimulating electrodes to make the stimulations, and receptor electrode to record the stimulation on oscilloscope. Let's see the obtained results. This is the obtained result on the screen of an oscilloscope. If you look to these stimulations, how many stimulations did we do? I, its intensity, 1, 2, 3, 4, and 5. These intensities are increasing, which means that I2 is higher than I1, I3 is higher than I2. So I1 and I2 don't give a response, don't record an action potential. So these two intensities are ineffective intensities because they don't provoke a response. While I3, I4 and I5 give a response, so they are effective intensities, while I3 is the first effective intensity, the first intensity that gave a response, the minimal effective intensity. It is called the threshold intensity. So, three definitions. Ineffective intensities are the ones that don't provoke a response. Effective intensities provoke a response. Threshold intensity is the minimal effective intensity, which means it's the first intensity that gives a response. Now we have to interpret these results. First, interpret means we have to make an analysis, then a significance. But the analysis of this curve of potential difference, it's not like any analysis of a line graph. No. The analysis is a relation between the manipulated variable and the result. The manipulated variable is the variable that we change, so it's the intensity of stimulation because it's increasing. We have two results. No response, no action potential like the cases of I1 and I2, or we have an action potential like I3, I4 and I5. So at I1 and I2, no response was obtained, while at I3, the first response was recorded. Now we have to mention the amplitude. We have to describe the amplitude during the analysis. The amplitude of the response, the amplitude is the height. The amplitude of the response remains constant while the intensity increases. We did the analysis. Now we have to write the significance. This indicates that the amplitude is not affected by increasing intensities. What can you deduce concerning the law to which a nerve fiber obeys? Deduce means we have to make a logical reasoning, then to write the conclusion. Since the nerve fiber didn't respond to ineffective intensities, while after the threshold it responds with maximum and constant amplitude. No matter how much we increase the intensity, then the nerve fiber obeys the law of all or none. All or none. We have two options. Either we have a response or we have no response. We don't have an option in between. We have no response if the intensity was ineffective, or we have a response with constant amplitude if the intensity was effective. After studying the response of a nerve fiber, which obeys the law of all or none, now we have to study the case of a nerve. So the same experiment is performed, but now on a nerve, which is a bundle of nerve fibers, and we have a stimulating electrode to make the stimulation and recording electrode to record the obtained response. This is the obtained result on the oscilloscope. We make I1, which didn't make a response, I2 also didn't give a response, I3 gave the first response, I4 the second, I5, 6 and 7. We notice that the amplitude from I3 till I4 till I5 is increasing, then it remains constant. It's the case of a nerve. I1 and I2 didn't give a response, so they are ineffective intensities. 3, 4, 5, 6 and 7 give a response, so they are effective intensities. From these 5 effective intensities, the first one is I3, which is called the threshold intensity, the first intensity that gave a response. We have to interpret the obtained results. So first, the analysis. At I1 and I2, no response was obtained, while at I3, the first response was recorded. After this threshold, the amplitude of the response increases, while intensity increases to reach I5, then it remains constant. As we said before, during the analysis, we have to describe the amplitude. The amplitude was increasing till I5, then it remains constant. If we don't describe the amplitude, the analysis is false. So this indicates that in a nerve, the amplitude is affected by increasing intensities, while in a nerve fiber, the amplitude is not affected, is always constant. To understand the situation of a nerve, we have to keep in mind that a nerve is a bundle or a group of nerve fibers. So we are not talking about one axon, we are talking about a group of axons. Let's explain each result. At I1 and I2, no response was obtained because no nerve fiber was excited. It's normal. Why the amplitude from I3 till I5 is increasing? Let's say, for example, that this nerve is made up of 10 nerve fibers. It's an example. At I3, the amplitude was this much. At I4, the amplitude increases. Then at I5, it continues increasing. Why? Why the amplitude is increasing, or when the intensity of stimulation increases? Because the number of excited nerve fibers increases. For example, if, as I said, that this nerve is made up of 10 nerve fibers, at I3, for example, 3 nerve fibers are excited. So we obtain this amplitude. While at I4, when we increase the intensity, 5 nerve fibers were excited, so the amplitude increases. While at I5, the 10 nerve fibers, all nerve fibers constituting this nerve, were excited, so the amplitude is maximum. So because the number of nerve fibers increases, at I6 we continue increasing the intensity, but all nerve fibers are already excited. So if we increase the intensity, the amplitude will remain constant. I will repeat. From I3 till I5, the amplitude increases since the number of excited nerve fibers increases, while from I5 till I7, the amplitude remains constant since all nerve fibers that constitute this nerve are already excited. Now we have to deduce the law to which a nerve obeys, since the nerve responds with increasing amplitude to the increasing effective intensities, which leads to a summation, which means sum of generated action potential to produce a global potential of maximum amplitude. Then the nerve obeys the law of summation, because we add the generated action potential to produce a global potential of maximum amplitude. As an evaluation, we have to complete the following table to compare between the nerve fiber and the nerve. So pause the video and try to answer. The structure, the nerve fiber is one axon, while the nerve is bundle of nerve fibers or bundle of axon. The obtained response on the screen of an oscilloscope. This is an example of the obtained response. No response or a response of constant amplitude, while in case of a nerve the amplitude increases until it remains constant. So the amplitude is null or maximum, while in a case of a nerve is increasing. The law to which a nerve fiber obeys is the law of all or none, while that of a nerve is the law of summation. For the next time you have to study the summary sheet part 3.